Okay, we're going to make a start now. So welcome everyone to our GCSE Maths session. Today we're going to be looking at the area of a sector. And there was a starter question of what we've been through in our last lesson for you guys to have a go at. So please do type in your answer into the chat once you've got one. If you don't have access to the Q&A, I know some people don't have access to the Q&A. If you don't have access to the Q&A, you can scan the QR code, which is on the screen. And you can let me know any questions that you have through there, and I'll be able to answer them as well. We're going to make a start now. So I'm going to start off by going through this starter question on the area of a sector, on what we looked at in our last lesson. So going through this answer step by step. So it says the diagram shows a solid shape. The shape is a cone on top of a hemisphere. So remember, a hemisphere is just half a sphere. That's why it's a hemisphere. Okay. If you want a little bit more time, I can give you maybe 30 more seconds. But just for the purpose of the lesson, we'll have to begin. Okay, so just 30 more seconds for anyone finishing off, and then I'll make a start. Okay, we're gonna go through the answers now. So again, over here we have a cone at the top and it's sitting on a hemisphere, which is half of a sphere. It says the height of the cone is 12 centimeters. And it says that the base of the cone has a diameter of 10 centimeters, and we know that the diameter of the hemisphere is the same. It also has a diameter of 10 centimeters. We need to work out the total volume of this solid shape. So it's a cone on top of a hemisphere. So what we're going to do is we're going to work out the volume of the cone first, and then we're going to work out the volume of the sphere. And then we're going to add together the two volumes, and that would get us our total volume. Okay, so let's start off with the volume of the cone. Okay, so volume of cone. We're given the formula in the box. It's a third pi r squared h. Okay, so we have a third times pi times r squared, which the r is just the radius, and the radius is going to be half of the diameter. So if the diameter is 10, the radius is going to be half that. Okay, so the radius is 5. So it's going to be 5 squared, and then we're going to multiply by the height of the cone, and the height we're given is 12 centimeters. Okay, so we're going to multiply by 12. Now it says we need to give our answer in terms of pi. So we're basically not going to be using a calculator. Okay, so over here, 5 squared is 25. 25 times 12 gives you an answer of 300. And then 300 times a third gives you an answer of 100. So your answer of this is going to be 100 pi, because 25 times 12 gives you 300, and then 300 times third gives you 100, and then 100 times pi gives you 100 pi. So the volume of the cone is 100 pi. Then what we're going to do, so we've worked out the volume of the top part, we need to work out the volume of the hemisphere now, which is half of a sphere. We know that the volume of the full sphere is given over here. That's the formula for the volume of the full sphere. Okay, so what we're going to do is we're going to work out the volume of the full sphere, and then we're going to divide it by 2 because we have a hemisphere, we have half of a sphere. So we're going to work out volume of hemisphere by doing volume of sphere, work the volume of the sphere out, and then we're going to divide it by 2. Okay, so the volume of the sphere is just going to be 4 thirds times pi times r cubed. Now r the radius is going to be half of the diameter. So if the diameter is 10, the radius is going to be 5. So it's going to be multiplied by 5 cubed. Now, if we work this out, 4/3 multiplied by 5 cubed, that's going to get us an answer of 500 over 3. And then if we multiply that by pi, that's going to get us an answer of 500 over 3 pi. And this is your volume of the full sphere. But we don't want the full sphere. We want half of the sphere because we have this hemisphere. We have half of a sphere here. So all we're going to do is we're going to divide this by 2. 500 over 3 divided by 2 is going to give you an answer of 250 over 3 pi if you type that into your calculator. Okay, and we need to leave our answer in terms of pi. So we've worked out the volume of the cone and we've worked out the volume of the hemisphere. Okay, now what we have to do is we need to work out the total volume. The only way that we can do that is by adding these two numbers together, adding the volume of the cone to the volume of the hemisphere. So we're going to work out the total volume now. By doing 100 pi, add 250 over 3 pi. Okay, so that's what we're going to do. And when you do 100 at 250 over 3, you get an answer of 550 over 3 pi. Okay, and that's what your final answer is, 550 over 3 pi. Okay, so again, when you're working out the volume of complex shapes like this, when you've got two 3D shapes placed on top of each other, you're given the formula for the volume of each one. You work out the volume of the top shape, you work out the volume of the bottom shape, and then you add together the two volumes. So we worked out the volume of the cones by using the formula that we were given over here, and we got 100 pi. We worked out the volume of the hemisphere by working out the volume of the full sphere first. We worked out the full sphere because that's the formula that we've been given over here. And then we half it because a hemisphere is half of a full sphere. So the full sphere was 500 over 3 pi. We then divided by 2 because we don't want the full sphere. We only want half of the sphere. So we divided by 2. And that gave us 250 over 3 pi. Okay, and then to work out the total volume, you do 100 pi, add 250 over 3 pi, the volume of the cone, add the volume of the sphere, and that gave you your total volume of 550 over 3 pi. Is it not 350 pi over 3? It's not 350 pi over 3, because if you do 500 divided by 2, that gives you 250 and not 350. Okay, if you didn't understand, I'll run through it one more time. So when we're working out with this volume, if you've not watched the last recording, just make sure that you watch the recording again if you don't quite understand how I went over it. It's not 350 because you're just doing 100 at 250, but it's 250 over 3. So if we were to do this, 100 add 250 over 3, we need to convert them into the same denominators. This is over 1 at the moment. So you multiply this by 3, so you convert them on the same denominators. 100 times 3 is 300 over 3. Add 250 over 3, and that gives you an answer of 550 over 3. Okay, that's why it's 550 over 3 and not 350. The recordings are on our YouTube channel, so if you want to watch the recordings back, you can just visit our YouTube channel, MediBrain UK, and you can watch the recordings. They're also posted in our WhatsApp group after each session. Okay, but just one more time, over here we're given a compound shape. We're given the formulas how to work out the volume of each 3D shape. The top shape is a cone, so we worked out the volume of the cone first. Okay, so you work out the volume of the cone by using this formula that you've been given and you get an answer. And then at the bottom you have half a sphere, you have a hemisphere, and a hemisphere is just half of a sphere. So we work out the volume of the sphere by using this formula over here, and that gives us the full volume of the sphere. And then what you do is you divide your answer by 2, because we don't want the full sphere, we want half of the sphere. And then once you've got that, you add the two volumes together and you get an answer of 550 over 3. Okay, and remember, it's not 100 over 3 add 250 over 3, it's 100 add 250 over 3. You can type into your calculator and it will get you 550 over 3. You can convert if you want. 550 over 3 can give you 183.3333 reoccurring. You can leave it like that and pi at the end. But because that's a reoccurring decimal, I just left it as 550 over 3 as a fraction, just so I don't have to write a reoccurring decimal. Okay, so that was a bit of a recap from our last lesson. What we're going to move on to in today's lesson is the area of a sector, and we're going to be looking at arc lengths. Okay, now before we start, I'm going to go through a bit or a few key points that you need to know. First of all, you need to know how to work out the area of a circle. And most of you will know how to work out the area of a circle, but just stating it, the area of a circle is pi r squared. Okay, so you have a circle, and then the r stands for the radius. The radius is half of the diameter. Okay, it goes from the center and touches the edge of the circle, which is the circumference. To work out the area of a circle, you do pi times r squared. The next thing that you need to know is that angles around a point add up to 360. Okay, so if you have a point over here, the angles around a point, they sum to 360. That's the second point that you need to know. Okay, and finally, what is a sector? A sector is literally just a part of a circle. Okay, so if we know that this is a circle, a sector is something like it's basically a part of a circle, so it's something like this. Okay, I know that's a really bad drawing, but it's something like that. It's just a part of a circle. Okay, or it could be something like this. This is a sector. It's like if you think about a pizza and you take a slice of the pizza out, that's a sector. Okay, it's just a part of a circle. Okay, so these are key points that you need to know. I'm going to go through an example now, and then I'm going to give you guys an exam question to have a go at yourself. Okay, so in an exam, how can this come up? What do I mean by around the center? Okay, so if I said to you, we have a line, and I said to you, what do the angles on this line add up to? Okay, we're working out this angle over here. Okay, and that would be 180 degrees. If I said to you a right angle, okay, we know that a right angle adds up to 90 degrees. Similarly, if you just had a point and you wanted to know what the angles around a point add up to, all you would do is you're working out the whole angle there. And that just means that angles around a point add to 360. Okay, so that just means around the center. So if you had a dot around that point, the angles add up to 360. Okay, it'll make more sense when we look at this question over here. So it says the diagram shows a sector. We know that it shows a sector because it's part of a circle. It says the radius of the circle is 8 centimeters. Okay, so this 8 centimeters that you can see is the radius of the circle. The angle of the sector is 150 degrees. We need to work out the area of the sector. The way that you work out the area, so if we take it step by step, we know that the area of a circle is pi times r squared. And this will give you the total area of the full circle. However, in this case, we don't have a full circle. We just have a part of the circle. Angles in a circle, let's say you had a full circle, the angle where from the center, so this angle around the center adds up to 360. A sector is just a part of a circle. Okay, so this is a sector. If you take out a pizza slice, that's a sector because it's part of a circle. Okay, so the angles around the center, they add up to 360 degrees in a circle. Okay, so in this case over here, we know that the radius is 8 centimeters. Okay, so that means we can work out the area of the full circle, because we know to work out the area of a full circle, we can do pi r squared. However, we don't want to work out the area of the full circle. We want to work out the area of just 150 degrees of the circle. Okay, so we know that in a circle, the total angle adds up to 360 degrees. Okay, so the total angle, this is the total angle in a circle, adds up to 360. And if you have a 360-degree angle in a circle, that means you have the full circle. Okay, so we have 360 degrees in a circle. That's the full circle. However, in this sector, we don't have 360 degrees. We only have 150 degrees. We only want to work out the area which has 150 degrees. So basically, out of a total of 360, we only want 150. Okay, we only want the area of 150 degrees. That's it, out of a total of 360 degrees. And then we're just going to multiply this by the area of the full circle. So multiplied by pi multiplied by r squared. Now r is 8, so r is just going to be 8, and then you're going to square it. Okay, so if you think about it over here, the reason why we have done that, angles around a point, they add up to 360. Angles in a circle, if you had a full circle, the angle in the full circle is going to be 360 degrees. But we don't have a full circle. We just have 150 degrees of the full circle. In a full circle, you have 360 degrees. That's the total. But we only have 150 degrees. That's why you have 150 out of a total of 360. We're only given 150 and it's out of a total of 360. Okay, so that's why we have this fraction over here. And we're just going to multiply that to the area of a full circle. And the area of a full circle is pi r squared. Pi times r squared. Okay, so we're going to multiply it by pi, and then we're going to multiply it by the radius squared, multiplied by 8 squared, because the radius is 8. Okay, and this you can just type into your calculator. So if you do 150 over 360 multiplied by pi multiplied by r squared, that's going to get us an answer of 83.775841. Okay, so it's, if you type that into your calculator, you can answer of 83.775841. And it says give your answer to 3 significant figures. Giving it to 3 significant figures, we count significant figures. So 1, that's the first significant figure. 2, that's the second significant figure. Okay, 7, that's the third significant figure. Then we look at the number after it. The number after it is 7, which rounds up, so that's going to increase the third significant figure by 1, which means that you're going to have 83.8 to 3 significant figures. Okay, and that's how you work out the area of a sector. Okay, so to work out the area of a sector, you know that angles in a circle add up to 360. You're going to take the angle that you've been given and you're going to put it over 360. You're then going to multiply it by pi, and then you're going to multiply it by r squared. Yeah, the answer is to 83.8. Why did I divide 150 by 360? So basically, whatever angle that you're given in a sector is anything that's not a full circle. you're going to get that sector, that angle, and you're just going to put it divided by 360 because that's how much of the circle that we've been given. We have a total of 360 degrees in a circle, but we've only been given 150. That's why the angle that you've been given in your sector, that is always over 360. And then you multiply it by your normal area of a circle. Okay, so your answer is 83.8. The radius is 10 because it says in the question. It says radius of the circle is 8 centimeters, and anything from the center to the circumference is 8 centimeters. Okay, we're now going to move on to our next question. If you guys have any questions, remember you can just let me know at any point in the Q&A, and you can scan this QR code if you'd like. Okay, so here's our next question, and it's very similar to the question that we've just done. Okay, so have a go at it. If you're stuck at any point, let me know. I'll give everyone 2 minutes, and then I'll start going through the answers. Yeah, this is a 3. It looks like a 5, but it is a 3 here. You don't need to draw the diagram. You can just work it out from the question. Okay, I see a lot of good answers. I'm going to go through the answers now. If you're still having a go at it, please keep continuing. I'm just going to go through the answers now. So on your calculator, there should be an SD button to convert it into a decimal if you're getting your answer in fraction form. If you click the SD button, you should be able to convert it into a decimal. Yeah, the last slide is here. Okay, we're going to go through the answers now. So first of all, this is a sector. It's part of the circle. And we are given the radius as 15.2, the angle as 165 degrees, and we need to calculate the area of the sector. So remember, when we're calculating the area of a sector, all we do is we do angle that you've been given divided by 360. You multiply by the pi, multiplied by all squared. Okay, so we're given 165 degrees. So it's 165 divided by 360, and then we're going to multiply by pi, and then we're going to multiply by the radius squared. So the radius is 15.2, so it's going to be 15.2 squared. And if you type that into your calculator, 165 over 360 multiplied by pi multiplied by 15.2 squared, you're gonna get an answer of 332.673781, and then it does say to give your answer to 3 significant figures, and because it says that first significant figure, second significant figure, third significant figure, 6 rounds up, that means we're going to increase this by 1. Okay, so our answer is going to be 333 centimeters squared. Okay. So, moving on. Okay, yeah, so we'll do this question and then we'll move on to arc length. So again, you need to work out the area of this sector. Okay, I'll give you guys 2 minutes, and then once you get an answer, you can type your answer into the chat, into the Q&A. Okay, just 1 more minute and then I'm going to go through the answers. Okay, I'm going to start going through the answers now. So it says the diagram shows a sector. So again, it's part of the circle, so it's a sector. We know that the radius is 11 meters. Okay, so that's what we're given in the question. The radius is 11 meters. Over here, we know that the angle of the sector is 200 degrees, and we need to work out the area of a sector. So the area of the sector is just going to be the angle in the sector divided by 360. Then you're going to multiply it by pi, and then you're going to multiply by the radius squared. So the radius is 11. So you have 11 as your radius, and then you're going to square it. Okay, so the angle is 200. So it's going to be 200 over 360 multiplied by pi multiplied by 11 squared. That's what you're going to type into your calculator. Okay, so 200 over 360 multiplied by pi multiplied by 11 squared. And that's going to get you an answer of 211.184839.5. And it does say to 3 significant figures. So your first significant figure, second, third. Your fourth significant figure, 1, rounds down. So this number is not going to change. So it's going to be 211 as your final answer. Okay, so 211 is your final answer there. So now what we're going to move on to is arc length. Now, arc length is basically when you have a sector, but instead of working out the area inside the sector, you're working out the length of the arc. So for example, let's say we had this over here, and this is our sector. Okay, it's part of a circle, so it's a sector. And instead of working out the area of this sector, we're going to work out the length of this arc that I'm shading in now. This arc, that's what we're going to work out the length of. Okay, we're going to work out how big that arc is. And again, there's a very similar formula that you need to know for arc length. Okay, so again, prior knowledge that you need to know how to work out the circumference of a circle. Okay, so to work out the circumference of a circle, let's say you had a big circle like that. To work out the perimeter of the circle, the distance around the edge or the circumference of the circle, the formula that you would use is pi times diameter. That's the formula that you would use. Okay, and d is just the diameter. So we have the center of the circle, and basically when we have a line running through the center of the circle, that's the diameter. So when you're working out the circumference of the circle, of a full circle, you do pi times diameter. Okay, that's the formula that you would use. Okay, and again, the fact that you need to know, same as your area of the sector, is the angles around a point add up to 360. Okay, so in the center, around the center, the angles, they add up to 360. Okay, and those two are the key points that you need to know. And now I'm going to run through an example now, and then I'm going to give you guys an opportunity to have a go at a question yourself. Okay, but you need to know how to work out the circumference of a circle. The circumference is just the perimeter around a circle. That's pi times diameter. And the way to work this out is very similar to the area of a circle. So going through an example, we've got an example over here. It says AOB, so AOB, that's our sector. Okay, we're given a sector, it's just a part of a circle, like a pizza. And it has a radius of 18 centimeters. The angle of the sector is 125 degrees. We're given that in the sector. We need to calculate the length of the arc AB. Now, when it says AB, that just means going from A all the way to B. Okay, we're going to try work out the length of that arc. Okay, that's our aim. Okay, now how do we work out the length of an arc? The formula that you would use. So we know that to work out the area of a sector, you would use the formula angle divided by 360, because in a circle the angles add up to 360, multiplied by pi multiplied by r squared. When you're working out the length of an arc, you're going to use a similar formula. You're going to use the formula of angle over 360 multiplied by pi multiplied by diameter. Okay, because again, angles in a circle add up to 360. And when we're working out the length of the arc, we're basically working out sort of the perimeter of this arc. That's it. So we have angle over 360 multiplied by how you would work out the circumference of a circle, pi times diameter. So in this case, um, when you're given the radius, to get the diameter, you have to double it. So if the radius is 18 centimeters, you have to double it to get the diameter. So the diameter is going to be 36 centimeters. Okay, so that's what the diameter would be. So in this case, the angle that we've been given is 125 degrees. So we have 125, and then we divide it by 360, and then we multiply by pi, and then we multiply by the diameter. The diameter is just double the radius, which means that it's 36. So we just multiply by 36. And that is what you type into your calculator. So we have 125 over 360, and then we multiply by pi, and then we multiply by 36. And it says give your answer in terms of pi. Okay, so because it says give your answer in terms of pi, you're basically just going to multiply the numbers and leave the pi there. And if you multiply the numbers, you're going to get 25 over 2, and then you're just going to be left with pi. Yeah, or you can have had 12.5 pi. Okay, yeah, you could say that as well. Okay, as long as you have the pi there. If you were to work out the full circumference, then it would just be pi times diameter, which means it would be 36 pi for the full circumference. But we don't want the full circumference. We just want the length of this arc. We don't want the full circumference. Okay, and to do that, we do 125 over 360, angle over 360, multiplied by pi, multiplied by your diameter, which is just double your radius. And then you leave your answer in terms of pi because the question said leave your answer in terms of pi. Okay, so I'm going to give you guys an opportunity to have a go at a question now. So I want you guys to have a go at this question. Okay, once you have an answer, you can type in your answer into the Q&A and we'll go through the answers in around 2 minutes. Okay, if you don't have access to the Q&A again, you can scan this QR code that we have at the bottom. Okay, so I'm going to go through the answers now. So it says we're given a sector. We know that the radius is 6 centimeters, and we know that the angle that we've been given is 60 degrees. We want to work out the length of the arc AB. So going from here to here, that's the arc AB. Now, to work out the length of the arc, we're going to use our formula, which is angle over 360 multiplied by pi multiplied by diameter. Okay, now the angle that we've been given is 60, and that's over 360. We're then going to multiply by pi, and then we're going to multiply by the diameter. Now, what we have been given is the radius. Okay, so to work out the diameter from the radius, we need to double it or multiply by 2. So it's going to be 12. So we're going to multiply by 12. And it says leave your answer in terms of pi. So we're going to leave pi like that, and then we're just going to multiply our numbers. So 60 over 360 multiplied by 12. And that's going to get us 2. So our answer is going to be 2 pi. Okay? So that's how you would work out a question like that. So our answer is 2 pi centimeters. Okay? So we'll have a go at this final question and then we'll move on to a block kit. So have a go at this question. and then type your answer into the chat. Be careful with this question. You're not just working out the arc length, you have to work out the total perimeter of the sector. So the first thing that you're going to do is you're going to work out the arc length. Once you've worked out the arc length, you have to work out the perimeter. And remember, the perimeter is just all the distance around the shape, the full distance around the shape. Yeah, we will do a block after this question. Okay, I'm going to start going through the answers. Now, if you're still continuing with the question, continue with the question and type in your answer in the Q&A when you've got one. Okay, so it says AOB is a sector of the surface. So we're given a sector. We know that the radius is 5.2 centimeters, and we know that the angle in the sector is 80 degrees. We need to work out the perimeter of the sector. Now, how do we work out perimeter? Perimeter is the distance on the outside. So the perimeter of the sector would be 5.2, add 5.2, add whatever this distance is. That would get you the total perimeter of the sector. So we need to work out the length of the arc first. So arc length, that's what we need to work out first. And to work out the arc length, we do angle, which is 80, over 360, multiplied by pi, multiplied by the diameter, which is going to be double the radius. So we're going to double this radius of 5.2, and that's going to get us 10.4. Okay, so we're going to multiply by 10.4. So if we type that into our calculator, 80 over 360 multiplied by pi and multiplied by 10.4, that's going to get us an answer of 7.26056968. And then we know that this is the length of the arc. Now, all you're going to do, once you know the length of this arc, you need to work out the perimeter of the shape. So you need to add 5.2 onto it and another 5.2 onto it. Okay? And when you do that, you're going to get an answer of 17.66056969. And it says, give your answer to 3 significant figures. So first, second, third, 6 rounds up, so that's going to increase this by 1. So your answer is going to be 17.7 centimeters to 3 significant figures.